Remember that in physics, energy is never created or destroyed, only transferred. In this video, we are going to discuss the transfer of energy and how this occurs in two types of systems, open and closed. So, what exactly is a system? In physics, when we refer to a group of objects or a specific object, we call it a system. Essentially, a system is just a collection of matter. This could be a battery and a fan, the sun and solar panels, or a human, a tennis racket and a tennis ball. They all interact with one another through energy transfer. Now that we understand what a system is, let's explore the different types. In an open system, matter inside can exchange energy with its external environment. This means it can gain or lose energy through interactions with its surroundings, allowing energy to flow in and out. For example, think of a campfire. It transfers energy to the surrounding air as heat and light, while it loses energy as the wood is burned. In contrast, a closed system is isolated from the outside world and does not exchange energy or matter with its surroundings. This means that neither matter nor energy can enter or leave the system. While energy can be transferred internally, the overall change remains zero. For example, consider a sealed, insulated container of hot water. Although heat may circulate within the water, the system as a whole does not gain or lose energy from the external environment. Let's look at some additional examples of energy transfer. We'll begin with an open system by examining a truck braking to avoid an obstacle on the road. When you apply the brakes, the truck's kinetic energy, essentially its energy of motion, must be transferred to reduce its speed. This transfer occurs through mechanical work. As you engage the brakes, friction between the brake pads and the wheels produces heat energy. The truck's kinetic energy is then transferred to the brakes and dissipated as heat into the surrounding air. This process effectively slows the truck down and serves as a prime example of an open system, where the truck loses energy to its surroundings and heat energy is released into the environment. In this scenario, the truck's energy doesn't simply disappear. It transforms from motion into heat and is released outside the system. This illustrates the principle that energy is never destroyed, only transferred. Let's explore an example of energy transfer in a closed system using ice cubes. Imagine you have a sealed, insulated container filled with ice cubes and a bit of air above them. This setup is a closed system because no energy or matter can enter or leave. As the ice cubes sit in the container, they start to absorb thermal energy from the surrounding air. Even though the system is closed, energy transfer is happening within the system itself. The thermal energy causes the molecules in the ice to vibrate faster, leading to the process of melting. As the ice absorbs energy, it changes from solid to liquid. In this case, the energy is being transferred from the warmer air to the cooler ice cubes, causing the ice to lose its solid structure and become water. However, because the system is closed, the overall energy remains constant. So in this closed system, total energy is conserved. The heat lost by the warm air is equal to the heat gained by the ice and water. Let's quickly recap. In this video, we explored energy transfer and the two main types of physics systems, open and closed. In an open system, both matter and energy can move in and out, like in a campfire where heat and light spread to the surroundings. A closed system, however, is separate from the outside world, so neither matter nor energy can enter or leave, like a sealed container where heat only transfers within. So whether in an open or closed system, energy is always on the move, being transferred and doing work, but never disappearing.